Hey everyone, this is Sagar from Tulip. Today I just want to quickly go over this new integration that we built within Tulip for an Onshape connector. It uses the basic Tulip OAuth 2.0 functionality to get the access token so that you can access Onshape's API. We built a bunch of connector functions essentially that gets different documents, works on getting information on metadata on the part studio, the assembly, the bill of materials and what have you, right? So I will quickly go over all the functionality that you can leverage from within Tulip, and Onshape has a great API Explorer documentation, and you can build your own endpoints as well. But we'll be providing a set of endpoints that you can have them imported onto your instance. So to begin with, just the first function here gets all the documents that are part of my Onshape workspace. So for instance, gear assembly, assembly test, and test. These are the three document names that I have on my Onshape workspace. If I quickly scroll to Onshape, these are the ones that we were able to pull from within Tulip. So let's say I would want to work with gear assembly to begin with. So I will get all the different information on different parts that are needed, the bill of materials, the dimensions for the part studio. So first thing, getting all the elements of a document. So this is nothing but once you're in a document, there are different tabs that you can pull in, and those are basically called as elements within Onshape. So you have part studio, an API Explorer application, and the assembly, bill of materials. So you can pull all of this information. It's nothing but just getting the metadata of all the elements that are present. If I go and first work with, let's say, Part Studio, we can do and get some Part Studio properties. This will pull in the metadata for Part Studio properties. You got to select which Part Studio you want to work with. So essentially, this is the gear parts, the different parts that would be needed to build this gear assembly. And then you can get the Part Studio body details. Essentially, Onshape returns a lot of data in this connector function, and that's why it takes a bit of time to get the response back from the server. These are the different body IDs of these parts that we would be working with. So if you select a specific ID, I can get individual part details for that specific part. So you see how GS7D has a different property ID, has property name and schema ID that you can use. These are all, again, depending on specific use case. Based on that, you can either leverage all this information that we're pulling in, or you can just exclude them as well. So just wanted to put something out there so that it makes it to your instance. And finally, if we're done with Part Studio body details, we want to go back to getting the bounding boxes of a Part Studio. This pulls in the dimension of a bounding box for a specific Part Studio, so you can see how we get the low Z's and the high X, the high Y, the high Z, the low X, and the low Y. So you can pull these dimensions also. Again, really depending on what use case you have with Onshape, we're providing you this connector function. And now moving to pulling in information on the gear assembly itself, which is of more use here. So getting, again, just like we were pulling in Part Studio properties, you can pull in a gear assembly properties. You can get an assembly definition, what that assembly is. So essentially, different instance IDs, the instance names that would be used, and the part IDs that we saw in the Part Studio side of things. So those could be different based on how you configure things on Onshape side of things. And then finally, putting in the part and the instance side. And again, getting bounding boxes of assembly, this also pulls in, the different dimensions of the bounding box for a specific assembly. Earlier, we were doing it for a parts and different part in the part studio, but now this is for the assembly. So that's really the difference here. And finally, the more important one is, if you use Onshape to pull in information into Tulip, different parts that are needed to assemble, let's say a gear assembly, you can pull in the bill of materials for that specific gear assembly. So over here you can see all the metadata on the gear assembly side of things, the ID, the document. You would need to pull these in order to pull the actual BOM. And finally, if I put it in, you can see that we can get the list of bill of material items, the names, the items, the part numbers, just the description, the material, what product line it's made a part of, the unit of measure, what have you, right? So you can configure your BOM on Onshape based on what document you're really working on. You can pull that into Tulip, build like a work instruction app or a dynamic work instruction app that is freely available in library on top of Onshape, and you can just combine the Onshape connector with all the apps that are available. So it just holds out to be a good combination. If I navigate to Onshape real quick here, this is the one that we were working on, the gear assembly on the Onshape side of things. Oops. I would let that load. Hopefully it should be back soon. Yeah, there we go. And just wanted to quickly show you the flattened BOM type that we were able to pull into Onshape, like the quantities, the part numbers, the description. So you can configure all of that over here, and those could be brought into into your Tulip instance. So as a part of the Onshape connector. So just wanted to quickly demo this Onshape connector. If you guys like this, this would be available soon in the library. You can have it imported onto your instance. Thank you.